Hi everyone, in this video we are going to solve one more problem. The problem name is invert binary tree and the problem number is 226. Alright, so first of all we are going to see the problem, we are going to see what this problem says. After that we are going to see the logic part, how we can solve this particular problem. And after that we are going to move to the implementation part and we are going to implement a solution or logic in C++, Java and Python programming language. Alright, so now let's discuss about this problem. Let's see what this problem says. Given the root of a binary tree, invert the tree and return its roots. Alright, so one line of problem. So we are given the binary tree and binary tree is nothing but guys a tree which can have at max two children, right? So at max two node can a root node can have at max two node, right? Alright, and here also guys we are going to see a invert. So we have to invert this tree, right? So what does basically mean by invert? So guys, invert is nothing but it is same as mirror, we can say. We have to find just mirror image of this tree. And also you can see in example 1, this image is nothing but a mirror image of this particular tree. And if you don't know what mirror image, then let me tell you, let's say this is a guy. Alright, this has two hands, left hand, right hand. So guys, in the mirror, what it will look like? So if I say this is a guy and this is also left hand, right hand. So if I change the just color, so I can say this is nothing but guys, this initially this was a left hand, right? And this was a right hand. So I can say this is left hand, right hand. But in the mirror image, this left right hand will come on the left side. All right, I remove that neck. All right, so this right hand will come on the left side and this left hand will go on the right side. I hope this much makes sense, right? So in mirror image, yourself can find that your left hand goes in the right side, right? So we just basically swapping the hands, right? So in the tree also it will gonna happen. If I just take this particular tree, example one, we have 4, then we have 2, then 7, then we have 1, then we have 3, and 6 and 9, right? So this is basically a tree, right? So now if I say that nothing, this root is nothing but a head of a person. So I will simply write here. So because head is not going to swap, right? Head will remain same. Okay. Now guys, we have 2 and 7. This is nothing but a left hand. This is a right hand. Okay. So left will come on the right side and right will come on the left side. This is basically happening over here, right? So we are going to do the same thing. Right will come on the left side. So 7 will come on the left side and this left will go on the right side. Means we are swapping it. So 2 will come here. So you can see that we have swapped 2 and 7 will gonna look like 7 and 2. Alright. So we have solved this particular problem for 4 node, right? Now we have to solve this problem for 2 and 7 node as well, right? So now we are going to solve this problem for 7 node and then we will solve this problem for 2 node. So 7 is now look like we can say human body. So 7 is a head, 7 is not going to swap, but their child will swap. So child is nothing but 6 and 9. So 9 will come here and 6 will come here. Same for 2, 3 will come here and 1 will come here. So now you guys, you can observe that this is nothing but answer, right? You can see here in example 1, we are getting the same answer, right? So what we are doing, we are just simply swapping the node of a particular root node, right? We are taking a node and we are just swapping their children. And at max, this binary can have 2. So we are very sure that we are going to swap left and right node, right? So now we are going to see how we can do this particular thing, right? So let's see that I'm going to scroll a little bit. So guys, what I can do, I can say this is nothing 4, 2, 7, 1, 3 and 6, 9. This was a problem, right? So what I can do that guys, you can see here. So what I can say firstly I will say 4 is fine. We have a root node, we are not going to do anything. But this left side, so let me change the color. So this left side will come on the right side. So I can say 2, 1 and 3. And this right side will come on the left side. 7, 6 and 9. I hope this makes sense, right? Now guys, once we have done these things, we can say we are solve the problem for 4 node, right? All right. Now what we are going to do, we are going to say 4 has been solved completely. Now let's solve the left part of 4. That is nothing but now 7, right? So we can say left part is nothing but a 7. So this 7 will gonna come, first of all, let me write same thing. Now guys, this 7 will gonna swap also their children. So 7 is nothing but now has 9 and 6, right? So 9 will come on the left side and 6 will come on the right side. So now we have solved the problem for 7. Now we are going to move to solve the problem for 9 and 6 and they are don't have any children. So you can assume that, but this are gonna written like same only. So we can say 4, 7, 9 and 6 and 2 and 1 and 3. So if we do same thing, they are going to look like same, right? So don't need to do anything. Now let's solve the problem for the 2 as well. So we're going to say 4, 7, 9 and 6 are same. So for 2 also we are going to swap the children. So we can say 2 dot left means 2, the left part of 2 should come on the 3 and right part should come on the 1. But did you notice that guys? There is an error. If we are making a changes for left node, then the right node should gonna delete it, right? So you are not getting it. Let me make it clear. So initially this was a tree, right? So I say that the left part of this tree should be right part, right? So I just say that this part should come on the left side. So I made it, right? So this has come on the left side. But now the actual left side has become this one, right? Alright, so this has been overwritten with this one. So where is that particular part? I want this particular part 2, 1, 3. Where can I get this particular part, right? Because I have seen that this particular whole thing should swap with this particular part, left part, right? So I can easily I can say that is, guys, this part is going to be deleted because this will overwritten, right? So how I can save this particular part? Because I can say that just for now, just make this particular node, just take this particular node in a different variable. I can say left side should contain now two nodes and 1 and 3, and now you can swap it, right? So it will come to 713 769, and the left side, which is nothing but now a left side, 2 comma 1 comma 3 is gonna be this one. I know it's a little confusing, but just for now, just think in mind that 2 comma 1 comma 3 has been swapped with 7 comma 6 comma 9, and we need 2 comma 1 3 for putting this on the right side. So for that, we can use our variable which is left side, which we have pointed to this particular one before swapping it. So now I can say left side dot 4 comma right should be a left side. Left side is nothing but 2 comma 1 comma 3. I hope this much is clear to you. Now guys, once we have done this, we can swap this particular also. 3 comma 1 will come here. So we can simply say a should be root left should be equal to right side. We can say for right side, let right, and root right, we can't say it should be left side. We can't say this should be a left side because left side has already been changed with the right side. So we can say left side we are going to store in one variable lr or ls, which is nothing but root dot left. Right, and now we can say root dot right is nothing but left side. So this is basically we are doing. After that, we can simply return our root. I hope this much makes sense what we are doing it. So let's move to the implementation part, and there you will definitely get an idea what we are doing and how we can save a particular left part or right part. So let me open here. So here guys, first of all, we are going to solve for Python. So I'm going to say if not a root, then we are going to simply return root, right? But if it is a root there, then we can say root dot left part should be self dot invert tree root dot right part, right? But before that, we have to save this left part as well. So I can say root dot left part should be stored in my left side. All right. Now once we have done this particular thing, we can say root dot right part should be equal to self dot invert tree root dot not root dot, we can say left side, right? And after that, we can simply return our root. So this is basically we are doing. So if I run this code, it will gonna accept it. I definitely let me see whether I have still a doubt. Yes, it is accepting. And why we are doing this? Because you can see we are swapping two numbers. So if I comment here, if I say a is 4 and b is 6, right? So for swapping, you use a temp variable so that b variable should not lost, right? You say that temp should store now a, and you can say now a is 6, right? So we lose a part, but we have stored a b inside of a, right? Then we can say b should store temp because we know that a is stored in temp. Same we are doing this. Left part we have stored b, right part, and so as we have stored the right part in left side, so we are storing losing a left side, right? So already we have stored left side in a left side variable. So I hope now this much is clear to you. I have explained it a lot. Now let's try to submit this code. You can see that it's successfully accepted. All right. Now let's solve it for a C++. So what I'm going to do, let's change it. Here guys, I'm going to say if root is equal to null. All right. And here we can say return simply root, right? And if it is not the case, then store in a left part, right? You can store right part as well. So tree node, we are going to say left side is going to be root dot left. All right, and after that we can say root left part should be equal to invert tree root right part, right? And after that we can simply say, okay, let me decrease the size. Here I can say left side, here I can say this is going to be nothing but right part. And after that, once we have done this, we are going to see return root. Let's run this code and submit this. All right, yeah, accepted. Let's try to submit this code, and I believe it should submit it, right? So you can see that it's successfully submitted. Now guys, we are going to do with a Java programming language. So let's take it Java. And same here we are going to do, we are going to say if root is equal to null, you can simply return root. and we can say root dot left, or we can say tree node. First of all, let's store the left side. So tree node left side is nothing but we can say root dot left, and we can say root dot left is should be equal to invert tree, and here we can say root dot right, right? And same we are going to do root dot right is equal to invert tree. Here we are going to pass our left side. Once we are done this, we can say return loop, right? So this is basically a program. I believe you must now understood that how we are solving this particular problem, and it accepted. Let's try to submit this code, and it also submitted, right? So now guys, I believe you understood this problem. You know how we solve this particular problem. You know what we have, why we have stored the left part in a left side variable. So if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.